So, all right, everyone, we look at mathematics of finance now. So, in mathematics of finance, we look at, I think here we need to look at applications of AP and GP. Is that okay? In finance application, because anything that do with finance, I mean together, it's always, it's usually involving some kind of sequence. Yes, it's involving sequences either in AP or in GP. Yeah. Everyone's know about finance. Finance is usually sequential. So quickly, one way or the other, look at what defines sequence, types of sequence, and other things like that. So what is the idea of sequence? I'll quickly explain because we have, I don't want to produce a lengthy video on that finance. So sequence are just series of numbers. Is that okay? Series of numbers that follow a particular pattern, or numbers that follow a specific pattern. Look at this. If I have this now, I have 3, I have 7, 11, 15. I think in your mind now you should have gotten the next number because that is following a specific pattern. So the next number should be 19, 23, and so on. So this is a particular sequence. The numbers here are in sequence in that manner. So you can say I have 19, I have 17, 15, 13, 11, 9, and so on. This is another sequential operation. Is that okay? So now, based on what we have here now, we can also have another flows of sequence. So another flow of sequence which we can actually have might actually be in this manner. We can have this in this manner. We can actually have 3, 6. We can have 12, 24, 48, and then so on. So another one we can actually have 2 might be, we can have we can actually say we have 12, we have 4, we have 4/3, 4/9, and so on. Now, you see this set of sequence here, the first 2 sets that I wrote, yeah, they are called AP. AP means arithmetic progressions. Is that okay? If you look at the first sequence now, we do add 4 to a previous, is that okay? No, term to get the next term. For instance, we are adding 4, we add 4 to what? To 3 to get the second term, because we got 3 the first term, and that is denoted as A. So A is equals to the first term. So if I say A, I'm referring to the first term. You see that thing is the first term. Once I write A. So our first term is what? Is A, which is 3. Which is A. So if we add 4 to 3, it will give us 7, which is our second term. If I add 4 to 7, it will give me what? 11, which is my third term. If I add 4 to 11, it will give me 15. And it's continuing that way. So that is because, okay, another one is this. My first term here is 19. Let's talk about that first, the second one. So if I subtract 2 from 19, I will have 17. 2 from 17, 15, which is the third term. 2 from 15 to get the fourth term, that will be 13. 2 from the fourth term to get the fifth term, I was about to, that will be 11. 2 from the fifth term to get the sixth term, that will be 9. And it's continuing that way. So now, you see those constant numbers, we are either adding or subtracting. Is that okay? We call this common difference. So if we, in a sequence, any sequence in which we are adding or subtracting a common constant, called the common difference, is called arithmetic progression. So in an arithmetic progression, we normally do add, is that okay? Or we subtract, we're getting every succeeding terms, is that okay? By a constant term called the common word difference. So these first 2 sequences now, they are AP because we add or subtract a constant key. So our common difference here is actually 4, positive 4. So our common difference here is minus 2, meaning we are adding minus 2 to each one, which is subtracting at the end. Is that okay to get the succeeding term? So therefore, our common difference is always a particular term minus a term before it. So for instance, I can say my common difference is second term minus first term, because term before it is first term. Another way to define my common difference is to say my third term minus second term. This means T3. Another one to define it, another way to define it is to say my seventh term. If I know seventh term, what term comes before seventh term? The sixth term. So a term minus the term that comes before it will give you common difference in every AP. In every word AP. Now GP. GP means geometric progression. Geometric progression. GP. Now, any sequence in which we are multiplying by a constant term called common ratio in getting the succeeding term is called geometric progression. Again, any sequence in which we are multiplying by a constant term called common ratio, not common difference, called common what? Ratio, is called geometric progression. Now, if you look at the first sequence now, we have 3, 6. Well, what are we doing? We are multiplying that by 2. We multiply the first term 3. Our first term is still A. So A is 3 in this sequence. But the common ratio, not common difference now, because it's GP, is 2. So 3 times 2 will give us 6. 6 times 2 will give us 12. 12 times 2 will give us 24. So we are multiplying 2 by a particular term. We have to get the next term. So that constant 2 is called common ratio. And that is denoted by R. Yes. So in this case now, what are we doing? We have 12, 4. We have, look at the relation. We have 4 over 3, 9 over 3. So here I'm dividing by 3, or I'm multiplying by 1 over 3. Yes. So here now, our common ratio R is in ratio. A term, that's the second term, is always a term, that's the second term, a term, that's the second term, divided by the term before it, first term. So a term, second term minus the term before it. Let's say first term. So that is what I will explain from there. Let's say the first. I will show it to you. Let's say the first term. So T2 over T1. It can be T3. The T3 now. Term that come before T2. T3 now is actually 2. So T3 over T2. Or T6 over what? Over T5. So that will give you common word ratio. That's why I like define sequence. So we have two main types of sequence. We will consider arithmetic progression and geometric progression. Thank you. So now let's talk about the first type of sequence, which is arithmetic progression. This is kind of progression, arithmetic progression, AP. Now, in AP, what we have to compute is what we call the nth term of the AP. Sometimes we might be required to get a particular term. It might be the fourth term. It can be the 100th term. We'll be waiting and waiting time and be getting say, how will I get the 100th term? Then it's just for you to apply a formula. So if n means any particular time you want to look for. To get the nth term, is that okay? Any particular term. The formula is simply first term plus open bracket n, which is that term, which is the term I of minus 1 multiplied by common difference. The common difference is the constant number we are adding or subtracting. It can be positive, that means you are adding. If it's negative, that means what? You are always subtracting. You get the subsequent term by that constant number. So this is the nth term here. Now, we will talk about some of the first nth term of an AP. What this means is that sometimes we can say, how can we in one way or the other get the sum of all particular terms together from the first to a particular term. For instance, I can get the sum of the first 10 terms of an AP. That means if I sum all the first 10 terms together, what will be the sum? We first of all list all 10 terms and solve them. That is the long way. So we can use this formula to get sum of the first 10 terms of any AP. And the formula is actually n divided by 2, open bracket 2a plus n, or open a bracket n minus 1 multiplied by d, close the big bracket. Or we can use this, which is similar to it, n over 2, what we are writing, a plus last term, yes. So if you know the last term, like for instance, if I'm looking for some of the first 10 terms, if I know the 10th term, I can always use this. If I'm looking for the sum of the first 25 term, if I know the 25th term, I can use this. But if you don't know the 25th term, you must know the first term. N is 25, so n is 25 in formula. So you must know the first term and the common difference. With that, you can get some of the first any number. Even now, you know the first term and the common word difference of that particular word sequence. So we use either this, but the last term must be known here. Because if the last term is known, then you know where we are actually going. So we can use the sum and use the nth term, and we are actually good. I hope you will actually have a good understanding of that. So now we actually explain arithmetic progression. Can we teach ourselves geometric progression before we start taking questions? So I will rub this up now. So our knowledge of geometric progression. Progression. So in geometric progression, we can always get the nth term too. Is that okay? Yes. Sum of the first nth term. So for a GP, the nth term, you're getting the particular term, the nth term, is that okay? Tn is always a r raised to power minus 1. So we say 8 times r raised to power n raised to power n minus 1. So we say the first term times common ratio to the power of, so this m and 1 is the power of common ratio. With that, you get any term. You know the first term and the common ratio of the term. You can get any particular term. Yes. If I want to get the 61st term of the particular sequence, I can get that. You know what the common ratio is, is the first term known, and good. So I will just say the first term multiplied by the common ratio to the power of the common ratio, 61 minus 1. If I am looking for the 61st term. So some of the first nth term of that particular GP is equals to, I know all of this formula very well. So I employ it as I'm writing, you can always pause the video and in one way or the other, just try and write something down or jot something down, and with that you are good. So some of the first nth term of a GP is given as the first term, open bracket r raised to power n minus 1. You won't stand on the zone. The zone is the power. It's on like this. So it's not on the zone. It's on like what they have here. So it's stand on the zone. But I'm not reason to the power. It's standing on its own, one way or the other. So minus 1, close bracket, all divided by r minus 1. Or the formula is the same thing. Sum of the first n term will be a first term multiplied by 1 minus r raised to power n over 1 minus r. We use this one if r is greater than 0. Yes. If r is greater than 0, and we use this if r is less than 0. Note, r cannot be 0. R can't be 0. Is that okay? R cannot be equals to, how cannot be 1 rather? It can be 0, but how cannot be 0 and 1? So, how cannot be 1, sha? But if R is 1, it will be what? It will be on the prime. And if R is 0, you are not forming any sequence. So, but R cannot be, you are forming 0, 0, 0 level sequence. So, if R is 0. So, but if R cannot be 1, because it's beyond the prime, yes, level sequence. Common ratio cannot be 1. It's beyond the prime. We have the same number or 2. So, if R is greater than 1, is out than 0, like in fraction, you use this, you greater than, and if it's less than that, you use this. Is it 0 or 1? I think it's 1. Let me not make a very big mistake. Is that okay? Let's say 1. If R is greater than 1, you use this. Is 1 actually. But if R is not less than 1, you use this. And also R cannot be equal to 1. Yes, it's not 0, it's 1. So if R is greater than 1, you use this one. And if R is less than 1, you use this. And R cannot be 1. So I think I pointed myself as this. So I'm very sure actually. So it takes reason to actually try to remember this. So R must not be equal to 1. If R is 1, it will be only 1. So if we don't have anything greater than 1, it's better to use this. Actually, you can use either for anyone, even though if R is there. But if R is less than 1, you can use this. But it will waste your time. It will not give you a quick answer as you want. You have to do some operation and things like that. So it's better to use this, just like a reverse. So if R is greater than 1, start with R first, use R minus 1. But if R is greater than 1, start with this. Is that okay? It's as simple as that. I think it gives us a lot of knowledge and understanding. So we use this now for sum. So some of the first nth term of the GP, like summing all the terms to a particular term together in the GP, we call that series. So we sum it together. But this one, sequence, you are getting a particular term in nth term. Can I do the 18th term? If you have first term and common ratio, can I do the 18th term? We are good, you can get that. So that will actually explain everything here in GP. So I think we can turn ourselves to solving question. We are good with AP and GP. So yeah, we have AP, we talk about AP and everything, and we talk about, and we are good with finance. So we have a lot to go. You say, yes, a sequence instead of numbers that follow a definite pattern. Yeah, they follow a particular pattern. We are giving 7, 12, 17, 22. What is the common difference there? Common difference there is 5. We are adding 5. The first time is 7, A is 7, and the second time is 12. We have 5 to the first time, we get 12, and it's continuing that way. Here we have 256, 64, 16, 4. That is GP. And our first term is 256. Our common ratio is 4. Yeah, we are dividing each by 4. Our common ratio is not 4, it's 1 over 4. It's T2 divided by what? T1. Or T4 divided by T3. Or T3 divided by T2. And that will give us 1 over 4. So we multiply the first time by 1 over 4 to give us the second time. So all of this there define what sequence. So arithmetic progression, I've told you, we are increasing or reducing it, or we are adding or subtracting a constant number and getting the subsequent term. And all of this there are just story. I've given you the nth term formula. So this is some of the first nth term. We use this n over 2 n plus this is the same thing. Now let's solve. What does the question say? A says find the 12th term of AP. What is in the AP? The first term is 7. The common difference there is, you can take second term minus first term. And that is what? That is 13 minus 7 is 6. Or you can say 19 minus 13, third term minus second term, you are good. So that is our common difference. So we have to get the 12th term. So to get the 12th term, we use nth term of what? Of about 8p. Do you remember? Try to remember. Good, you have remembered. It is 8 plus n minus 1 multiplied by common what? Difference. So our n is 12. So we are looking for the 12th term. The 12th term will be equal to 8. Common first term 7 plus 12 minus 1 multiplied by common difference 6. So we have 7 plus 11 times 6. So it is 11 times 6. So we have 7 plus 66. And our answer will be what? 73. Yes, 7 plus that is 73. So that is actually our 12th term. That is A has been answered. So this says find the difference between the 8th term and the 52nd term of the AP. So first we need to get I will need to get my 8th term. My 8th term will be, what is the AP? First term of the AP is actually 210. Common difference will be what? Will be 205, second term minus first term. And that will give us minus 5. Hope I'm not too fast. You can always take the video back. The first term, the second term, I said a term minus the previous term. So we can't use 210 minus. That is the first. So you say second term 205 minus 1 minus first term. Or you say third term minus second term. So it's minus 5. So the second common difference is minus 5. And the question answer we should find the 8th term. So our T8 is actually first term plus 8 minus 1, that is 7, plus 7D. So next time, if I want to write any term, I'll just say 8 plus 1 minus that term. Is that okay? So 8 minus 1, I'll subtract 1 from the term. So get that. In AP, is that okay? The 8th term of any term is 8 plus 7D. 100 term is 8 plus 99D, like 100 minus 1. Is that okay? What will be 200 term? Here reason. That will be what? 200 term will be what? The formula will be, to get that 200 term will be 8 plus 199. So 200 minus 1. So 199D. So 8 plus 7D now is our 8th term. So to get that, we will say, now A is actually 210 plus 7 times minus 5. So we'll say 210. 7 times minus 5 will give us minus 35. What is 210 minus 35? That will give us 175. I think I'm right. So that is our 8th term. So now, what is now our 52nd term? 52nd term, T52 will be 8 plus 51D. Yes, 52 minus 1 times D. So 52 minus 1, our formula. 8 plus, this formula here, you can apply. You can, if this theory, you can state the formula before you start applying. That means Tn is equals to 8 plus n minus 1D. That is the Tn. So if you get to 8, we have put 8 in that formula, it gives us this. So same thing applies here. So 51. So what is our A? A is 210 plus 51 times minus 5, common difference. So we have 210 minus 51 times minus 5, that is minus. And minus what? Minus 255. 255. And what is that going to do? That will give us minus 45. So what are we going to do? Find the difference between 8 and 1. That will be 8 minus 2 term. So that will be, we are saying 8 term minus 2 term. So we have 175 minus 45. And our answer will be what? Minus and minus is plus. So we have 175 plus 45. And that will give us 220. The difference is 220. So the difference is what is 220. Now, she said now, okay, she said find the sum of the first 10 term of the AP. Question A and B. So let's use the plus, let's use the graph when we're getting that. Sum of the word of the first. So is AP. In question A and B. A is AP. So we have to get the sum of the words. Sum of the first. I'm sorry, I forgot. So sum of the first 10 terms is okay of A and B. So to get sum of the first 10 terms, we are looking for S10. Our S10 in AP is n over 2, open bracket 2A plus, we don't know the last term, so 2A plus n minus 1 in small bracket times Z and big bracket. That is D. So now, for the first question, our first term, which is A, is actually 7. As you can see, for the first one, the D is 6. We are now to find the sum of the first 10 term. If you know the last term, you can use n over 2 open bracket 8 plus n last term, but we don't know it, so we use this one. Now, then our S10 will be equals to n is 10, sum of the first 10 terms. So 10 divided by 2 multiplied by 2 times, what is our A? Our A is 7 plus 10 minus 1, I'm sorry, plus 10 minus 1 multiplied by common difference, what? 6, close big bracket. So we now say we have 5 times 14 plus 10 minus 1 is 9. Is that okay? 9 times 6 plus 9 times 6. No, you use your body mass. So 5 times 14 plus, what is 9 times 6? That will be 54. So 54 plus 14 will give us 68. 68 times 5. 68 times 5 will give us 340. The sum of the first 10 terms is 340. 340. So for that sequence, for the first sequence here, A, for the A is 340. Is that okay? That is the sum of the first 10 terms of that sequence. Now, the next question for us, the B. The first one has been done. The B now. The B is, we are still using our formula, which is n over 2, 2a plus n minus 1 d. Is that okay? So our A is 210, which is the first term. Our B is minus what? Minus 5. Our D is minus 5. Common difference. In the second question. So we are looking at some of the first 10 terms. So our x10 will be equals to 10 over 2, open bracket, 2 times, what is the first term? 210 plus 10 minus 1 times minus 5. So we will say we have 5 times, or 10 over 2 is 2 times 210 is 420. No, plus 9, 10 minus 1 is 9. 9 times what? Minus 5. So we have 5 times 420 plus 9 times, no, that would not be plus, that should be minus. So that would be 5 times 9 times minus 5 is minus 45, so minus 45. What is now 5 times 420 minus 45, then 10 times 5. So 420 minus 45 gives 375. So 375 times 5, that gives 1,875. So our sum of that is 1,875. So sum of the first 10 terms is 1,875. I think we have actually tried. So this is sum of the first 10 terms of the second sequence of this B. The sum of this, the total has got to be 340. So and that is that. I think let's take the next question. What does the next question say? How many terms of the sequence of the series they are already in sum? Yes, we sum all the series together. We'll be needed to obtain a sum of 870. That means our sum of the first n term, no number of terms, is that okay? So the first is 15, the second is 18, the third is 21. That means is AP, the first term is 15, the common difference is 3. Yeah, 18 minus 15 is 3. Or 21 minus 18 is 3. That's why you are going to know that is what is AP. So we have an AP, and we are about to get the SM, is that okay, of that. If the sum of all, because series is a sequence, but there will be a sum as far as series are concerned. So the sum of that series is 870. So how many times do we have in it? So we want to look for n, where Sn is what is 870. Let's go to the board and transform that. So our Xn, sum of the first n term is 870. So the first term there is 15. Common difference is actually 3. So what is the n term that will make this? So we'll say Our formula for our Sn is n over 2. Pay attention. 2a plus n minus 1d, then bracket. So we have to be smart. What is the Sn? It's 870. That is what the sum to. Equals to, we don't know what n is. We continue. 2 times 15, that is 2 times 15, that is our a. Plus, we don't know what n is, so our m minus 1 will remain. What is d? d? So we pick it up again and say 870. So if I were you, I can multiply all through by what? By 2. Let's multiply all through by 2. Because of this fraction, I hate fraction. When I taught you equation, I said, just multiply all through by that denominator of the fraction. So we already add only 2 as factor. But all of these here are single terms. Because this multiplied this, so they have made a single term. So this times 2 will give us what? I don't know what that gives us. 1,940. It will be bad if I made a mistake. Let me confirm. So what is 870? 870 times 2. So look at, I made a mistake. 1,740. Let's save it. So now that is times 2. Now n over 2 times 2 we have n. So open bracket. 2 times 15 we have 30. So plus n minus 1 times 3. So 3 times n we have 3n. 3 times minus 1 we have minus 3. And we have that. So we can say we have 1,740 equals to n. Open bracket. 30 minus 3 we have 27 plus 3n. So we can say we have 1,740 equals to n times 27, 27n, n times 3n, 3n squared. So I think we are here. So we arrange this equation, this quadratic equation. So let's bring this one here. So if we bring, we have 3n squared, the means on the other side, we have 27 plus 27n. We will not bring this one to the other side, because assuming the other side have a minus 1,074 equal to 0. So these are there, then you move down and minus, they will all sum towards to 0. Because we don't have any side or other side again. So that is equal to 0. Can I divide all through by 3? Let's try it, yes. So if I divide 1,740 by 3, the 3 divide it. I think 3 should be able to divide that. So 3 will actually divide it. Divided by 3, that is 580. So this divided by 3 is n squared. Because this divided by 3 is 9n. This divided by 3 is 580 equal to 0. So how do we solve that? Can we actually factorize? Okay, let me teach you how to get that. We know we have 5 times minus 580 times n. That is minus 580 n squared. So this is what we do. So we have minus 580. Let's think of factor of minus 580. Then we are going to sum that will give us plus 9. So we can just say, let me divide 580 by 2. So that will be 2 times 580. Divide 580 by 2 now. 2 times 580 is, what times what will give us 580? Let's divide 580 by 2. 2 times 290. So 2 times 290. You know, one of it has to be negative. So since I have positive, so if here is negative, but the big one we have plus 9. So the big one to be negative, positive. So if this there is positive and here is negative, they cannot be different. If it's something, they cannot give us plus 9. So let's still divide this now by 2. These 2 can go. So divide that by 2 times what will give me 290. So I think 2 out of 290. What remains? So that will be 145. Yes. 2 can no longer go. And if I pair these 2, 2 times 2, 4. 4 times 145 will give me this. But 145 is positive, this is negative. The difference cannot say give me plus 9. I will bring down 145. 2 times 2 will remain where they are. Can 3 divide 145? I think so. Okay, let us break down 145. Since we are using prime number, that you are doing product of prime number. Yes, we are explaining that number as the product of prime factor rather in primary school. So can 3 go? 2 cannot go in 145, everybody know. It's an odd number. So let's use 3. Can 3 go there? 3 cannot go. Wow. So 5 is the next prime number. So 5 times 29. So we say 5 times 29. So I think we are good now. Yeah. All of it are prime number. 29 is 9 prime number. So we are not dividing again. So we careful. If it's factorizable, we get that now. So 2 times Let's put these three together and leave this one alone. 2 times 2 is actually 4. 4 times 5 is 20. 20 times 290 will give us this. And if we have 29 is positive and 20 is negative, then what we are looking for is 20 times 29. So that we say minus 20 is 29. If we sum, it is plus 9. If we multiply, it's what we need. So the factors are minus 20 plus 29. So you reason and be picking up the factor. So we take the video, I show you the complex it and look at how to factor. So these are the two factors we are looking for. Let's stop this. So that means we say n squared minus 20n plus 29n. So the two we replace this one. Minus 580 equal to 0. So we pair. So we have n squared minus 20n in bracket plus 29n minus 580 equal to 0. So we have what is common? N is common, so I have n minus 20. What is common? 29 is common, and we have n minus 20 equal to 0. What is common? N minus 20 is common, so we have n plus 29 equal to 0. So both will be equal to 0. So n will be 20 and n will be minus 29. And n cannot be negative, so our n is 20. 20 times we sum to that. 20 times we sum to that. I hope we understand. So 20 times we sum to that. So 20 times we sum to that. So what is the solution? Let's compare that. Yes. We have 73. I hope we have 73 and that's 2. Yes, we do. So the 8th term of the second one is 175. The 22nd term is 145. The difference is now to 20. I think we have that too. Some in A, some of the first term in A is 340. I remember. Some of the